Thank you. Thank you for having me first. My presentation is about how to build multi-platform apps with Compose. I'm a Google developer expert in Kotlin and Android. And in this presentation, what I'll go over is how do you set up a project that uses the Compose library by JetBrains. And specifically, I'll go over how do you write your components, UI components in Compose, and share them between different platforms like Android, iOS, and desktop. So your UI doesn't have to be fully in Compose. You could embed a Compose view inside of a Swift UI view, and I'll share an example of how the interop works. And lastly, talk about architecture and navigation. Specifically, how do you handle setting up like your view models? And I'll go over libraries that exist now in the multi-platform ecosystem that allows you to set up architecture and navigation in a much easier way. So the JetBrains Compose library has support for these platforms. It has experimental support for iOS, and you could share now like UI components between these different platforms. So before this was introduced, it was easier to share API components. You could use Ktor to write an API client. And you could also build a caching layer using libraries such as SQLDelight. And you could also like write out your business logic and share them between platforms. So now you could write your UI components that you want to share. So the library that this is a library. This is the JetBrains version of the Compose library called Compose Multiplatform. And this library has experimental support for different platforms besides Android, like iOS. So the experimental support right now is web. And iOS just recently was announced at KotlinConf, which is like it has alpha support for iOS. So in my presentation, the motivation isn't to convince people to use it in production because it's experimental, but it's about exploring what's possible, exploring the challenges. So that's what I want to show in this presentation. So long ago, I gave a presentation here in Android Worldwide where I compared Compose with SwiftUI. And I built this app that displays a list of images. And in this presentation, I'm going to show how I took this app and made it so that it uses this Compose multi-platform library by JetBrains. This is an app that displays a list of images that are stored locally in the app. And when you click on them, it displays details about it. So how could you build something similar, or how did I convert this to have this whole UI in Compose? So I want to start off with the UI structure, how I structured the composable components. So the structure of the project is that there is an Android app, an iOS app, and a desktop app. Now, in order to make it easier for you to build something to try it, there are templates available. There's a template by JetBrains available that allows you to gives you a basic scaffolding of the project. And there is a shared folder that all these different apps rely on. The shared folder has 3 different source sets. You could also have a desktop source set here. And in this build.gradle file, what you'll see is that there's a plugin. There's a Kotlin multi-platform plugin that's provided to you. And what this plugin provides is that it allows you to easily like add dependencies like these on for different things. And you would add these compose dependencies in your common source set for UI, foundation, material, and runtime. So when in your common main, what will you add in there? How will you structure your UI? So suppose one way you could structure it is that in your common folder where you're going to share is you could have an app root view. You could have a composable function which defines, which is like the main root of your app. It defines the navigation to different screens. And your Android and iOS apps will basically utilize this app root view. That's one approach you could take if you want to build everything in Compose. But you could also take other approaches where you just pull in a composable function in your existing app architecture. That's also possible. So in your common main, what does the app root look like? For this app I made a file called imagesapp.common.kt. This is a good, a way, if you look at the example, you'll see this naming scheme where you have imagesapp.common, or if it was an Android, it will be .android.kt. So in here, what I'm going to define is a composable function called imagesapp.common that defines a scaffold and for the app. It defines a top bar and some form of content. So this is the main root of the app that you're going to share. This is the view you're going to share, and the Android and iOS apps will utilize this. So you could also share a theme between iOS and Android, and this is similar to how you define the theme on Android now, where you have your light colors and your dark colors for dark mode or light mode. And you define basically a composable function that you're going to wrap. And if it's going to change whether it's in dark mode or light mode. So you could also share, great thing is your theme in between platforms. So in addition to that, what you're going to do in your Android source set, in your Android, you're going to define in this shared module just the main Android method like this, and it wraps around the theme. So the other thing you're going to do in Android, the way you utilize this is that you have set content in which you're going to utilize the shared UI component that you built in this shared library. So in iOS is where things get interesting. How do you utilize this on iOS? On iOS, the library provides you with the way it builds a UI view controller that you could utilize in your UI. So what I have done here is that I've created a main iOS method in the iOS main source set. And the library, Jetpack Compose Multiplatform library, provides you with a helper method called Compose UI View Controller, and internally creates a view controller, and it kind of is the bridge between the iOS world and the Compose world. It creates a Compose layer, and in there I'm calling this method imagesapp.common, and it's returning a UI view controller that I'm going to utilize in my iOS app. So in my iOS app, how do I use that shared Compose component? So this is an example of how to use that component. There are 2 approaches you can take. One approach is to declare an app delegate and to declare this method right here to be your root view. That's one approach you could take. But you may also want to take an approach. Another approach you could take is that suppose you have an existing app that has Swift defined in Swift UI, and you want to just add in a shared component. So over here, I have a struct that I've defined in Swift, and I am basically defining a content view in Swift that I want to show. And the content view, internally, what it has is that it is going to utilize this compose view that I made. And this has a method, make UI view controller. So when you look at what I'm doing here is that when you look at this, main underscore iOS KT is a way to access things from my shared library. I'm accessing that main iOS method, composable that was made. It's returning a controller, as you saw earlier, and that's what this compose view is doing. So what I have here is a Z stack in Swift, and I'm in this Z stack underneath this compose view. I could have other things that I want. But what I'm putting into this Z stack is just inserting my shared view, compose view that I made. So this is really good if you want to share just specific components that are shared, not your whole UI. So in the Jetpack Compose Multiplatform library, you'll see examples of this that they have. They have an example of a to-do app that also shares how to do this. So, and what this will do is that when I run this app, it will show basically my app in the simulator, iOS simulator. So I went deeper and I looked at what does the view hierarchy look like? You know, what's being added to the view hierarchy when I run this? What's being added for the compose view? So when you look at the view hierarchy, you'll see it starts from the UI window, scene, VUI window. Then what you have is the compose window. This library adds this compose window abstraction, this layer that it adds. And then you'll see is that it has something called Seco UI view that it also adds in there. And the question is, what does that mean, and where does that come from? So this UI view that it's adding in there, it's basically from a drawing library. And when you look at this UI view hierarchy, what you don't see is basically Z stack or these other types of primary views. And what you'll see is this UI view, which is the root view. And in there, but where this comes from is an external another library by JetBrains called Seco. And basically what this library is that it provides Kotlin bindings to the Skia library. And that library is a library that allows you to draw on multiple platforms. And it's a graphics rendering library. And internally, Kotlin multi-platform, it's utilizing that for iOS to be able to render these the UI, these shared components. So that's what it's using internally. So far, what we created is this app root view that I'm utilizing on both Android and iOS. And this app root view is setting up the scaffolding for my app, and I could now write basically my other composable functions for my UI. So everything in Compose, things such as like canvas drawing and all those things, they will work on like both platforms. So how do we build something like this? How do I want to build this app, but I want to display these images in Compose. And when you go about doing that, you run upon your first challenge. And the challenge is that there's no image loading library. And it's easy on Android. You could use Coil or Picasso, but there is an issue open on Coil library that when you look at this comment by Colin, there is work where should make that this is in flux, in progress. And what you ideally would want is some image loading support in the JetBrains Kotlin multi-platform library. And so that's in the works. So when you look at Coil, it doesn't have right now Kotlin multi-platform support. So what I'm doing is that for this app I made, I have a list of resources that are locally in the app. They may also be external. And I want to show them. I want to load the bitmap. And this exercise of doing this, it was useful because it allows you to see how to use expect and actual keywords. So in common main, in order to have support for resources, there is actually a library that the JetBrains Kotlin multi-platform library provides. There's a component that you could add in called resources. It has utilities to be able to access your resources in a multi-platform way. And what I did is that I created an image provider. And what I have is that it returns a bitmap, image bitmap. So this method called resources is what's provided by this library, components resources. And I'm giving it a URL, local URL, and I'm basically getting the bytes. And then I have to define a method to be able to transform that into a bitmap. And that's where I could use expect and actual declarations. So how do you implement this? So expect and actual, you could use it also for composable methods, which is really nice. So for example, in my common main, I could specify an expect like this. I have an extension to byte array image bitmap. And then in my Android source set, I could basically do actual fun to byte array. And I could utilize these extensions that's provided to be able to get a specific bitmap from byte array. When you think about this, you obviously don't want to do this in production. It'd be good to have an easier way, a library to do it. But this is a good example of an illustration of how to use actual and fun for a specific use case. So now I could decode the byte array and get the bitmap. So in iOS main, I could use iOS specific dependencies to be able to decode the URL. So there's a method called make from encoded that gives me a bitmap. So this is an example of using actual and fun. And there's a utility called toCompose image bitmap that's provided by this library. So by the Kotlin multi-platform library. And then in my image provider, I now have a logic to be able to figure out how to get a bitmap locally from a URL. So how do I go about and utilize this to load in, to show this image, to use that bitmap? So I could create an images list composable function, which is shared. And it has a column lazy grid. And I'm going to display each image. I have a composable function called splash image. And the way splash image works is that I created a local a locale provider for my image, for the image provider that I showed earlier. And basically in there, I could go ahead and get the image bitmap by supplying the URL and then show it in the image. When you look at this, obviously this is doesn't really scale well, but one of the challenges, image loading, is that's something that's simple. What is a challenge? This is the same pattern that's used in the examples in the multi-platform library. So as I said, this is more like an exploration and challenges of what's out there right now. And in here, when I built this images list and I have the images loading, I want to be able to basically I will build a details page, and what I have built so far, what I'm sharing is this root view, which has the scaffolding. I have the images list and the images details page that my Android and iOS app are accessing. But how do you give data to these things? You would want to create a view model and use a repository. How do you go about doing that? So there are different approaches you could take where you could have the view models in these Android and iOS apps, or you could attempt to share them. And there are libraries that I'll show that provide lifecycle aware components. And that's the other challenge, is that how do you go and architect your app and set up navigation to go from a list page and a details page? So suppose I want to use MVVM where I have a view model that's communicating with the UI, and I'm giving it some UI state, and any events, I'm propagating them to the view model. So I could also share the view model between Android and iOS. You could also do that. So I could create a view model in my common folder, and where I have some UI state like loading, success, and error, for example. And I'm going to hand this off basically to my images list composable function to render all these different states. So I may have in my view model, I can't use view model scope because that's not multi-platform. I have to create my own, and that's one of the downsides. And I had to manage, canceling this scope, and I would create a state flow in here that emits some UI state. This is similar to what you would do on Android. So then I have an init method which communicates basically with some repository to get me images, and you could get those images. You could use Ktor, for example, to implement that repository to interact with an API client. So the downside with this approach, since I declared my own scope, I need to manage, canceling it and the life cycle of it. And I could utilize this in my app component where I basically get the state and then I give it to my images list screen. So the other part is, how do you set up the images list screen? So I'll display a loading, success, and error. And this is everything in that shared module. I have the list screen, the circular progress indicator, and an error state. After I have built the details and images list following this, I may want to obviously want to add navigation to be able to go from the list to the wrap root view, the list to the details page. And I could set up a list of screens, list, and then details, and what I'm going to pass to it, the image ID, to load the different tags. So I could create an images app. Comment in there in my app root view, I have a screen state, and I'm basically able to navigate to different screens in there. And I could update the screen state, for example, when you click on one of the images. So when you look at this, is a simple approach. Obviously, there's questions around how does this scale, right? So there are two, challenges here where that I don't have lifecycle aware components, and how do you set up navigation where you take into account going backwards, and you need some backstack management. And there is a library available that gives you these two attempts to solve these two problems, gives you these two features. It's called Decompose, which is a popular library, a multi-platform library that that has APIs that allows you to, gives you a child stack, gives you an API to specify, to navigate, to push and pop. And it gives you also lifecycle aware components. And how would I utilize this in the example that I just showed? So this is what Decompose do, two features that Decompose offers. And when you're using this library, you define components that you would provide to your composable functions. And these components are these components, they provide a value type and which is some form of UI state. You could plug in library, open source multi-platform libraries such as Reactive, and to be able to use coroutines with it. So over here, I have some UI state in this component, and that I'm providing. And I could in there also provide in this interface what's going to happen when I click on one of the images to be able to navigate. So I would provide a concrete implementation, and what this library provides you with is an access compose a component context that this library provides you with. And in there, I could specify basically for this value type, the mutable value with it that you want to update the state with, and I specify all my logic for that I want to happen. So this is the component that I would pass to my images list, and then from there I could subscribe. Over here, I'm subscribing a state, but this library has plugins for also for other libraries that you can use, such as the reactive library. So over here, I have the UI state that I'm getting. Then I could just show the error state or success state for it. So how do you set up navigation to a list component or a details component in this library? So the way you set that up is that you declare an interface for your root component in here. And this library provides you with a stack that you could push things to, that you could use. So it offers backstack management. So you specify, like in a seal class, what are the different components you have in your app. So I have a list component, a details component. And I'm going to define and utilize this navigation, the stack navigation API this library is providing you. So this right here, this also has animation support for it that I want, and I'm specifying the my initial screen, that will be shown, the list, which is the list screen, and I can inject in factories for my navigation. So I'm going to define here my configuration, which helps me to define, like, if I have a detail screen, I want to send in some data, like the image ID as part of it, what information that I want to send in to another screen. So over here, I have my list component over here that I'm specifying. So in this root component, I have defined all of the different components that's going to be used for the list component. And when in this images list, when something is clicked, I'm pushing basically onto the stack. I'm using that navigation API that's provided to me. So it's similar to the details component. When this library offers backstack management in a multi-platform way, so I'm calling the pop method to be able to pop from the stack. So the way you set this up, this is how you would set up navigation. And then in your root view that my Android and iOS app are using, and my desktop app would also use this, I have defined basically this library provides this wrapper called children, where I give the stack. And then I specify like all the different screens that I could navigate to, like just my list content, my details content. And I'm passing in the components that are going to help me to get the state and to show it. So The benefit of this library, again, it's multi-platform, has multi-platform support to set up your navigation. So it also has these lifecycle aware components. So in Android, if I want to use this library on Android, I could specify a default root component, and I could just provide that to my images app common composable method, which is in the shared library. Similarly, in iOS, if I want to use this on iOS, I could declare in my app delegate a root holder. And the root holder, basically, in there, I'm passing it to my compose view, as you could see. And in this compose view, I'm passing it the root component. So this is a great library to be able to solve those problems, and that I recommend that you check out. There is in the JetBrains Kotlin multi-platform library examples that they have for the to-do example that they have, and they use this library in there. So that's my presentation. I hope that was helpful to help you to see what's possible currently with Compose Multiplatform. And you don't have to share all your Compose. You don't have to build everything in Compose. You could build certain UI components. There are examples with how to do that. They have a to-do example that's written in Swift, but utilizes some shared Compose UI. I want to say thank you to the Android Worldwide organizers and for the opportunity to present here. If you want to learn more about coroutines or multi-platform or mobile, you can check out my blog at codingwithmohit.com. And I want to say thank you.
Thanks so much, Mohit. I actually enjoyed the talk. I think KMM is something I've been very interested in. I haven't really gotten to start looking into it yet, but this was very insightful and at least giving me an overview of what's out there. There aren't any questions in the audience. Actually, there is just one that popped up now. So this one is from Ryan. It says, I know it's not covered in the talk, but have you tried out Compose Web or JS at all?
First, hello to Ryan. I haven't tried out Compose Web. I'm just starting to learn about this library, beginning to explore it. I just tried it out for Android and iOS, but I know there are examples in there on Web and JS support.
Cool. And a question from my end was, so I saw there were elements where you were using Swift, right? So is this kind of a prerequisite? Can you get away with using KMM without knowing Swift, or do you kind of have to know the best of both worlds, Kotlin and Swift?
So you do have to know, obviously, what an app delegate is. Obviously, some backend, some prior knowledge of iOS, but I mean, you could build your everything, the whole app in Compose, but I mean, if you think about it, is that feasible? I mean, in the long, is that feasible for your project? Might be feasible for a greenfield project. There are other things to explore, which as UI performance, for example. I don't think everyone will build their app in Compose or convert it. If you have an existing app, there might be use cases where you want to maybe share some UI in an existing Swift project. But but that again is also, you could raise a lot of questions about that, on why not to do that. So it's very it's in the exploratory phase.
All right. And in terms of your experience, so you did mention all these challenges, but did you find that you enjoyed it, like its potential, even when you're building this app? Did you find it fun building it, or was it more around the challenges and just hoping that there'll be improvements in future? I mean, like even just the image loading.
I'm glad you asked that because I do have things to say about that. So one of the biggest problems was starting the project. The starter templates that there are many people who have starter templates. Some of them are outdated. So you go to build a project and then it tells you, well, you're certain versions behind in your Android Studio you're using. For example, you may be using Android Studio Preview. If your dependencies are behind, sometimes I found the project's built for me, but then when I go in the iOS app in Xcode, it's saying you have unresolved symbols. So then I had to figure out updating the project, the starter template project. So getting set up was it was a challenge. The development workflow is a challenge because if you were to go and build an app in IntelliJ, a Kotlin multi-platform app using one of their templates, you have this great that you're given the ability to build the app from IntelliJ. Like for iOS, you could go and run it from there. It opens up an iOS simulator. But that sometimes I found after doing an upgrade that breaks. You don't see that configuration and haven't figured out why. So you have to switch between Xcode and IntelliJ. So that there are improvements that could be made in the developer workflow. I personally wish there was an image loading library that was, because it's something which is simple, and but it wasn't. I think that when I built this, I thought about all those questions. I personally don't feel comfortable putting a view model inside of a shared library. I want that to remain separate. And it raises the question, what is it actually you want to share? And the last part to answer your question is that when I look at the view hierarchy in Xcode and you see the compose window, you see that question comes up is, if you dig more into that, how did that work? I wasn't able to find a lot of documentation. I did start reading the source code for it, still playing around with it. How is that being actually being rendered? I initially, thought that it would map to, for example, a Z-stack and all these primitive views in Swift UI, but it doesn't. And but I think, yeah, that's interesting. That was my experience just exploring this technology. I think it has a lot of potential.
Yeah. No, and I'm really sorry that was your experience, man. And I too hope that.
I mean, I don't feel bad about it. I mean, that's just whenever you're learning about something new, and obviously there will be challenges, but this is the learning process, right? This is the way.
This is the way. Ryan actually has a comment. He says, haha, it seems like KMM project setup and version control management is still a major issue. I found KDoctor was very useful for Android or iOS KMM setup.
So I did. Oh, thank you for sharing that, Ryan. I did also go into KDoctor, and you could download KDoctor. I believe that's an npm pack and node package, where it will go through and make sure your environment is set up correctly, whether you have CocoaPods installed. So that was something useful. Yeah, people should try that.
Nice. Yeah, those were all the questions. Thank you so much, Mohit. Yeah, this was really good. Yeah.
Well, thank you.
Yeah, thanks, man.